Hello everyone, good evening to all the grade 12. Today we're starting our first lesson in grade 12, that is patterns, sequences and series. So make sure you have your writing material, a pen and a piece of paper or a notebook so that you can take notes, because I'm going to be teaching some important stuff, basics, terminologies and formulas. So make sure that you listen attentively and take notes. So let's get started. Remember to like our Facebook page and also to subscribe to our YouTube channel and hit the like button and share the link with your friends, your colleagues, your schoolmates, your classmates. So let's get started. We are dealing with patterns, sequences and series. Alright, please don't hesitate to ask questions if you do not understand. Ask questions if you don't understand so that we'll be on the same page. Ask questions if you don't understand. So I'll be waiting for your questions, and also I'm gonna give you some classwork that you're gonna do live. Then you can send your answer via our chat room on WhatsApp. So let's get started. Hello grade 12, welcome to patterns, sequences and series. Knowledge and skills for this topic: a basic understanding of algebra, including the manipulation of algebraic expressions, equations and inequalities. So this is a prerequisite information or knowledge that you must have so that you will be able to master patterns, sequences and series. You need a working knowledge of simultaneous equations, a working knowledge of exponential theory and equations. You need quadratic equations, solution both by factorization and by using a quadratic formula. A basic working knowledge of logarithms and how to use logs to solve simple equations. So, content of final exam, so that is what is included on the final exam. Arithmetic, geometric and quadratic sequences and series are examinable. Remember, you learned about quadratic sequences form part of the grade 11 syllabus. A variety of questions will be asked, which will include knowledge and routine procedures, complex procedures, and problem solving. Determining the summative formula is examinable. So, we're talking about arithmetic and geometric sequences. Your success in this topic will be based on your ability to recognize and categorize the sequence as arithmetic or geometric. You must be able to differentiate and then to select the correct formula and algebraic tools to solve the problem. Arithmetic sequences and geometric sequences, what is the difference? So we start with arithmetic sequences. The general sequence is A, that is T1, A plus D is T2, A plus 2D is T3, A plus 3D is T4. A is the first term and D is the common difference. By definition, D is equals to T2 minus T1 is equals to T3 minus T4 is equals to T3 minus T2, or is equals to successive term minus previous term. In other words, the common difference is successive term minus previous term. Examples of arithmetic sequences. So we have in this sequence 2 is to 4 is to 6 is to 8. So what is the common difference? The common difference is successive term minus previous term. So is 4 minus 2 is equals to 8 minus 6, which is equals to 2. Another example, we have 4 is to 1 is to negative 2 is to negative 5. So the common difference, D is equals to 1 minus 4 is equals to negative 2 minus 1, which is negative 3. Another example, we have log x is to 2 log x is to 3 log x. So the common difference is successive term minus previous term. In this case, 2 log x minus log x, or 3 log x minus 2 log x, which is equals to log x. The general form or nth term is given by this formula. Tn is equals to a plus open brackets n minus 1 into d. A is the first term, or we call it T1. D is the common difference. N is the term number. N stands for the term number. So now let's go to geometric sequences. So the general form is A is to AR is to AR squared is to AR3. A is the first term and R is the common ratio. By definition, R is equals to T2 divided by T1 is equals to T3 divided by T2. So it means that the common ratio is equals to successive term divided by previous term. Examples of the geometric sequence. Here we have 2 is to 4 is to 8 is to 16. So what is the common ratio? So it's equals to T2 divided by T1. In this case is equals to 4 divided by 2 is equals to T3 divided by T2. In this case is equals to 8 divided by 4, which is equals to 2. And also we have another example. We have this sequence 3 is to 15 is to 75 is to 225. The sequence continues. So the common ratio R is equals to 15 divided by 3, that is T2 divided by T1. And also is equals to T3 divided by T2, which is equals to 5. So in summary, common ratio is equals to successive term divided by previous term. So the general form or nth term is given by this formula. Tn is equals to AR to the power n minus 1. A is the first term or T1. R is the common ratio. N is the term number. Value of the sequence. The value of A is the first value of the sequence, that is T1. Alright, so A is equals to 2 in this case. Then what is the common difference? D is equals to successive term minus previous term. So is equals to 7 minus 2, which is equals to 5. Right? Then now, using the general form, so now we're going to substitute the values of A and D in the general form, which is Tn, is equals to A plus open brackets n minus 1 into D. Right? So now is equals to now we have to substitute. A is in this case 2 plus open brackets n minus 1 into 5. The value of D is 5. Now remember, in order to master the sequence and series, so which means we have to know your algebra, right? So now we have to simplify this expression. So Tn is equals to 2 plus 5n minus 5. Therefore, Tn is equals to 5n minus 3. All right, let's go to the next example. So we have example 2. We're still using general forms and definitions. So consider the sequence below. Use the relevant formula to find a general expression for the sequence. So here we have 2 is to 6 is to 18. As you can see, this is a geometric sequence because 6 divided by 2 is 3, and also 18 divided by 6 is 3. So here Tn is equals to AR to the power n minus 1 is equals to AR to the power n minus 1. All right, so now let's substitute the values of A and R. All right, so in this case, remember A is always the first value, so A in this case is 2 and R is equals to successive term divided by previous term. So R is equals to 6 divided by 2, which is equals to 3. All right, now let's substitute to the general form. So Tn is equals to A, which is 2, times R, which is 3, to the power so is 3 to the power n minus 1, n minus 1. So this is the general term of this geometric sequence. Alright, if you have any questions, feel free to ask so that I can answer them with you. So let me give you a task based on what you've learned. Now, remember, maths is not about theory. We don't just talk and talk and talk and talk. As long as you're not the one doing it, you will think you understand. Meanwhile, you don't understand it all. So, the best way is to get some exercises. All right, here I have. All right, so let me align it. All right, so here, so this is a classwork. Given the sequence 11 is to 2 is to negative 7, find the value of n if Tn is equal to negative 169. So this is your task. Just write number 1. Make sure that you are doing number 1, because one thing about maths, if you are not the one writing it, you think you understand, then you'll be surprised during the exam that you didn't know anything. So given the sequence number 1, 11 is to 2 is to negative 7, find the value of n if Tn is equals to 69. All right, so I'm giving you just 3 minutes to complete number 1 only. Do number 1 only. Remember, you can send your script on our chat room as a proof that you are following. So let's get started. All right. So based on what you have learned, what kind of sequence is number 1? Is it an arithmetic sequence? Is it a geometric sequence? All right. You have been given the first 3 terms. So I'm waiting for your script. All right, we're left with 1 minute now. $30 remaining. All right, 15 seconds remaining. Okay, I left with 3 minutes to do number 2. Calculate the number of terms in the sequence. 3 over 2 is to negative 1 is to 2 over 3. So you have to determine whether is it an arithmetic sequence or is it a geometric sequence. So calculate the number of terms. Your time starts now. You're left with 3 minutes. Hello, I hope I'm being heard. So here we have Tn. This is the general form. Tn is equals to A plus open brackets n minus 1 into D. So the question says, given the sequence 11 is to 2 is to negative 7, find the value of n if Tn is equals to negative 169. So now we substitute Tn as negative 169, then the value of A as 11, and into n minus 1, then the value of D is negative 9. Then we simplify this equation. Then after simplifying this equation, we get negative 169 is equals to 20 minus 9n. Then we transpose, that is, we take this constant to the left hand side, so the sign changes. So it becomes negative 189 is equals to negative 9n. So therefore the value of n is 21. The value of n is 21. So this is our final answer. All right. So now try and get to calculate number 2. Number 2 says calculate the number of terms in the sequence. So now you are not given whether this sequence is it an arithmetic sequence or is it a geometric sequence. Based on observation, you have to decide whether it's an arithmetic or is a geometric, then apply the principles of an arithmetic if it's an arithmetic, and apply the principles of a geometric sequence if it's a geometric sequence. So now you are left with 3 minutes to find the solution of this expression. Calculate the number of terms in the sequence. 3 over 2 is to negative 1 is to 2 over 3. Right? Let's get started. I hope you're almost done for number 2, for question number 2. All right, so in 10 seconds time I will start doing corrections. Please make sure that you do it, because if you don't, you won't understand. So please make sure that you attempt. Remember, maths is for those who are not afraid to make mistakes. Maths for those who are not afraid to make mistakes. So it's better to make a mistake now than make a mistake during the exam time. All right. All right, so let's do the corrections here. I hope I'm being heard. So remember, you should always comment. If you can't hear me, you should always comment. So let's get started. Okay, we have this sequence. This sequence, as we have seen it, this one, it's a geometric sequence. So it's a geometric sequence. So now we have the first term, which is a. Remember, the first term is always a. So a is equals to, in this case, 3 over 2. A is 3 over 2 in this case. Now let's get the value of R, common ratio. So R, remember, R is equal to successive term divided by previous term. So in this case, I will use term 3 divided by term 2, because for me that one is the easiest. So is term 3 divided by term 2. Alright, so what is the value of term 3? Term 3 is equals to term 3 is 2 over 3, then divide by -1. Remember, in maths, any number divided by 1 is equals to that number. So therefore common ratio, R is equals to -2 over 3. Common ratio R is equals to -2 over 3, right? So now let's write the general form. The general form says the general form is Tn is equals to AR to the power n minus 1. So that's the general form. So now let's substitute. Remember, Tn in this case, Tn in this case is equals to, we are given Tn is equals to negative 16 is equals to negative 16 over 81. So now let's substitute in the general form. So here we have negative 16 over 81. So we have negative 16 over 81, right? Negative 16 over 81 is equals to A. The value of A is 3 over 2. The value of A is 3 over 2. Is 3 over 2, right? Times R. The value of R is negative 3 over 2. Then we open brackets. The value of R negative 2 over 3, right? Then to the power n minus 1. All right, now let's simplify. So remember, when we are doing introduction, when it comes to sequence and series, you must make sure that you master your algebra. That is essential, because if you don't, you'll be struggling. Okay, so what do we do here? Let's remove this 3 over 2 to the left hand side. How? So we're gonna multiply by the reciprocal, that is by 2 over 3. On the left hand side, we're going to multiply by 2 over 3. On the right hand side, we're going to multiply by 2 over 3, so that we can remove the 3 over 2. So here, so we're going to say all right, to have the fraction. So we're going to multiply by, we're going to multiply it by 2 over 3. 2 over 3 multiplied by negative 16 over 81. Okay, 16 over 81 is the same as, okay, 16 is the same as 2 to the power 4, then 81 is the same as 3. 81 is the same as, remember, on the introduction we said that you must be able to use your exponential equations. 3 to the power 4, right, is equals to, so when we multiply 2 over 3, remember, whatever you do on the left hand side, you must also do on the right hand side. So it's going to cancel 3 over 2. When you multiply 2 over 3 on the right hand side, it's going to cancel 3 over 2. So we'll be left on the right hand side, we'll be left with negative. We'll be left with negative of 2 over 3 all right, we had a yes, yeah. So we left with negative 2 over 3 negative 2 over 3, right into exponent n minus 1. All right, so now here on the left hand side, so remember, when the bases are the same, we take a single base and add the exponent. That is the exponential law or principle. When the bases are the same, we take a single base and add the exponents. All right, so now if we divide by -1 on the left hand side and divide by -1 on the right hand side, we're going to remove this negative. So we'll be left with 2 we'll be left with 2 to the power 5, 2 to the power 5, right, over 3 to the power 5, over 3 to the power 5 is equal to 2 over 3 all to the exponent n minus 1. So here let's put brackets so that you don't make silly mistakes. Let's put brackets. So this is what we left it on the right hand side. So now let's take a common factor. So remember, on the left we can simplify like this. So on the left we can say 2 over 3, then everything to the exponent 5, everything to the exponent 5, everything to the exponent 5, I hope you are following, is equals to the fraction 2 over 3, 2 over 3, then everything to the exponent n minus 1, n minus 1, right? So now when we apply our exponential principles or laws, whatever you might call them, so when the bases are the same, we equate the exponents. So we'll be left with, I hope I'm sleeping ahead. So we'll be left with 5 is equals to n minus 1. Remember, when the bases are the same, we drop the bases and equate the exponents. So 5 is equals to n minus 1, right? 5 is equal to n minus 1, therefore the value of n is equals to 6. Therefore n is equals to 6. So that's the value of n. N is equal to 6. So I hope you are following. All right, perfect. So yeah, okay, now I'm gonna give you just a task. This one is not that difficult, it's easy. Okay, so this one is number 3, question 3. So what I want to do in question 3, So here we have use a formula to find which term in the arithmetic series. Use a formula to find which term in the arithmetic series. Okay, let me just create a space. In the arithmetic series, which term in the arithmetic series? We have negative 71 is to negative 68 is to negative 65, right? And the series or the sequence continues. Is the first term to exceed 10? Solve this problem. Question 3. Question 3 says, use a formula to find which term in the arithmetic sequence. So you are given that this is an arithmetic sequence. In the arithmetic sequence, negative 71 is to negative 68 is to negative 65 is the first term to exceed 10. Remember, if you can see, these negative, they are descending, or I can say they are ascending in the positive direction. They are going to the positive direction. So we have negative 71. Now we're going up to negative 68. We're going up to negative 65, going towards the positive direction. We're going towards the positive direction. So now the question is, which term in this arithmetic series is the first term to exceed? In other words, is the first term to be over 10, to exceed 10. All right. So remember, maths is about questioning. So you're being tricked on the questions. So the principle is still the same. So get started. This one I'm giving you 5 minutes. Okay, you can start now. Only 5 minutes. I want you to attempt it. Try, just write something. If you don't know how to write, you can write it as it is, but just write something. At least try to think, try to solve the problem. Maths about problem solving. So use a formula to find which term in the arithmetic sequence. So we're given the arithmetic sequence, blah blah blah, is the first term to exceed 10. So we're given the first 3 terms. All right, I think you're left with 4 minutes now. So remember, when I was explaining, remember, maths is about theory. You must understand the theory behind every calculation. When I was explaining, remember, I said you must know your algebra, you must know your equations, you must know your exponential equations, like just what you did the previous one. You must know your inequalities. So sequence and series involves every algebraic tool. So you must know them all, solving for x, simplification, factorization, using factors, using a formula, and also inequalities are involved as well. All right, so I think you're left with 3 minutes now. All right. 2 minutes and a half remaining. Two minutes remaining. 2 minutes remaining. All right. One minute. All right. I hope you can see clearly now. So my screen was not clear. Use a formula to find which term in the arithmetic sequence negative 71 is to negative 68 is to negative 65 is the first term to exceed. In other words, is the first term to be more than 10, to be more than the value 10. 30 seconds remaining. 15 seconds remaining. Okay, so please make sure that what I need from you, just send me your script so that I can see where you got stuck. Just send me your script, yeah, because this one is a tricky one. It's not an obvious case, this one. Okay, it wants you to think outside the box, but everything you're given. Okay, here, remember, this is an arithmetic sequence. So what is the value of A and what is the value of D? Remember, when I talk about arithmetic sequence, you must have the value of A and the value of D. So A is always the first term. In this case, our first term is negative 71. Right? excuse me, what is the value of D? So, all right, so what is the value of D? Perfect. The value of D, okay, the value of D is equal to, successive term minus previous term. So it's gonna be, I'll use T3 minus T2. So it's equals to successive term T3 minus T2, then is equals to 65, right? Sorry, it's equal to negative 65 plus 68. Okay, let me put it in a negative 65 minus into negative 68, right? So D is equals to positive 3. D is equals to positive 3. All right. So now remember, when we are talking about arithmetic sequence, so you know that you have the general form. So the general form is Tn, right, is equals to A plus into n minus 1 into D, right? So what is the value of Tn? Remember, we are given the value of Tn. What is the value of Tn? All right, the value of Tn is 10. So Tn so Tn is equals to 10. You are given. It says that use a formula to find which term, we're looking for a term, which term in the arithmetic sequence negative 71 is to negative 68 is to negative 65 is the first term to exceed. In other words, is the first term to be more than 10, right? So now then the tricky part, that's where the tricky part comes in now. So I'll read the question again. It says use a formula to find which term, right, which term we're looking for, n, which term in the arithmetic sequence. Okay, let me just say n is equals to an unknown. So which term in the arithmetic sequence, right? Which term in the arithmetic sequence? Negative 71 is to negative 68 is to negative 65 is the first term to exceed 10, right? So what we do here, we'll say all right, we'll say okay, remember we're substituting Tn, right? Tn is equals to the value of A is negative 71, right, plus into n minus 1, right, times 3, right? But now, which means, remember, this whole thing is Tn. So which term is greater than 10? So remember, Tn is what? Is 10. So in other words, we'll say 10 is less than Tn. Because we want the term, because we want this n to be greater than 10. Remember, the n is on the right hand side. You see the n on the right hand side? So the n must be greater than 10. So we're saying 10 is less than this whole thing, this Tn, because we want the n to be greater, because asking which term is greater, which term exceeds 10. So which means that's why we say 10 is less than this expression. I hope you are following. All right, now solve for n. Right, so then we're gonna say 10 is less than negative 71, right? Then we say plus 3n minus 3. I hope you are understanding the simplification. Right? So here, then we say, let's simplify. So then we say 10 is less than, all right, negative 71 minus 3, then it's going to be negative 74. Negative 74, right? Plus 3n, right? Then now, let's simplify. Let's have the value of n. So we're going to say 10 plus 74 is less than 3n. We transpose. Remember, when you are transposing, in other words, when you are taking one term from one side of the equation to the other side of the equation, the sign changes. So the negative 74 on the right hand side, it was a negative. Now when it goes to the left hand side, it becomes a positive. So now we have 84. We have 84 is less than 3n. We have 84 is less than 3n. Find the value of n. Therefore n is greater than 28. Therefore n is greater than 28. So if n is greater than 28, so what is the value of n? Remember, we were just using the inequalities to solve the problem, but we want the term. Which term in the arithmetic sequence? We don't want which term, we want the term. Which term that is greater than 10? Which term? So we say now, since n is greater than 28, therefore n is equals to 29. So this is our final answer. Therefore n is equals to 29. Okay, let's recap. Okay, here question number 3 was saying use a formula to find which term in the arithmetic sequence, right? Which term in the arithmetic sequence, right? Okay, this is just a general question. Which term in the arithmetic sequence? We are not given the conditions. Then what is the arithmetic sequence? Negative 71 is to negative 68 is negative 65. Now that's when the condition starts. The condition says, is the first term to exceed 10? Is the first term to exceed 10? So in other words, Tn is equals to 10, right? Tn is equals to 10. This is our Tn equals to 10. Then now, what is the value of A? The value of A is always the first term of the sequence. Then D is the common difference, because we are told that is the arithmetic sequence. Then now, we have this general form. We're gonna use this general form, right? But us, we wanted a term that is greater than 10. So which means this, whatever it is, it should be greater than 10. In other words, 10 should be less than. So 10 is less than the general form. 10 is less than general form. In other words, 10 is less than n. Remember, we want n here. 10 is less than n, right? Remember, n is on the right hand side. That's why we use the great. That's why we say 10 is less than instead of saying 10 is greater than. I hope you understand. That's why we said 10 is less than the general form, because this thing reads like this: 10 is less than the general form, or the general form is greater than 10. You see? Then now you use your algebraic manipulation to simplify this expression on the right hand side. Then we got 84 is equals 84 is less than 3n. Then we divide by 3 on the left, on the right hand, on both sides. We said 3n divided by 3, we're left with n. Then 84 divided by 3, that is 28. Remember, here we say 84 is less than 3n. So in other words, 3n is greater than 84. So our answer will be n is greater than 28. So as we didn't want a number that is greater, we want the actual number. So the actual number is 29. So n is equals to 29, because we were being asked which term. Which term, you see? So the term is 29. So n is equals to 29. One more last class work, then we'll be done for today. Then I'm gonna send the homework. One more. So this one is nice. All right. So here it says number four. Okay. Number four says calculate the number of terms. Calculate the number of terms. Calculate the number of terms in the sequence. Calculate the number of terms in the sequence, and we're given this sequence. So the sequence is 5 is to 10 is to 20 is to, it continues. Then we have 81,920. All right, let me repeat the question again. Calculate the number of terms in the sequence. I hope you can see it clearly. Okay, seems like it's not appearing. Yes, now it's appearing. Yes. So number 4, it says calculate the number of terms in the sequence. So we are calculate the number of terms in the sequence, right? The sequence 5 is to 10 is to 20 continues. Then we have 81,920. So this one is almost the same as what we did here, but I'm giving you just 4 minutes on this one. It was not difficult. 4 minutes to complete it. Please, I need your rough work. I need your rough work. All right. Three minutes remaining. Two minutes remaining. One minute remaining. Number four, I think is the easiest. Is the easiest above from the previous ones that we did. So number four should be the easiest. All right. One minute remaining. Calculate the number of terms in the sequence. 5 is to 10 is to 20 continues 81,000 continues 81,920. All right, 30 seconds remaining. Please make sure that you attempt, because if you don't, you will think it's easy. Make sure that you attempt. Write. If you don't know what to write, just write your name and your surname. If you don't know what to write, and send me the script. Thirty seconds remaining. Fifteen seconds. 10 seconds. 5 seconds. 2 seconds. Time up. All right, so here. Alright, here's the script from one of the learners. Alright, okay, perfect, awesome. Alright, yes. Okay, so here so by observation you can tell this one is a geometric sequence. How? You say 10 divided by 5, that is 2, and 20 divided by 10, that is 2. That is the value of r. R is equals to 2. And remember, a is always the first term of the sequence. So when we're dealing with the geometric and the arithmetic sequences, what we need the value of a and d for arithmetic and a and r for geometric. That's what we need. All right, so here, so this is a geometric sequence. So we have a is equals to the first value, 5 in this case. Then we have r is equals to successive term divide by previous term, so r is equals to 2, right? Then we have tn, sorry, I say t2, tn is equals to 81,920, right? So now let's write the general form of a geometric sequence. So the general form of a geometric sequence is as follows. Tn, that one you know it by heart. Tn is equals to a r to the power n minus 1, to the power n minus 1. Okay, let me just put a space in between. So then let's substitute our values. I just copied this, so let's substitute here. We'll have 81,920, right? The value of a is 5. The value of r is, okay, say times, the value of r is 2 to the power n minus 1. So then now, remember we're solving for n here. When you are solving, you are free to divide, to multiply, just to remove the coefficients. So here we're gonna say, so it's gonna be So it's going to be 81,920 divided by 5. You can press that in your calculator. 81,920 divided by 5 is equals to 2 to the power n minus 1 is equals to 2 to the power n minus 1, right? Then when you press that in the calculator, you will have 81,920 divided by 5 is 16,384. Then is equals to 2 2 to the power n minus 1. Remember, sequence is one of those topics that combines everything in algebra: simplification, inequalities, equations, expressions, what else? Exponents and exponential equations. So it combines everything. So you are free to use anything that works for you. Remember, in maths there are no laws. You can use anything as long it is a principle. As long it is a principle. All right. So here, so when you change 16,384 to the x to base 2, so it's gonna be 2 to the power 14 is equals to 2 to the power n minus 1 is equals to 2 to the power n minus 1, right? So when the bases are the same, we drop the bases and keep the and equate. We drop the bases, that you put the base aside. We drop the bases and equate the exponents. So if we equate the exponents, it's gonna be, so what is the exponent on the left hand side? The exponent on the left hand side is 14. It's going to be 14. What is the exponent on the right hand side? The exponent on the right hand side is n minus 1. Solve for n. Then when you solve for n, that will be n is equals to 15. So the number of terms 15. So n is equals to 15. Thank you so much for watching. If you have any questions, remember you are free to ask questions. You can on our Facebook page, or you can ask through our WhatsApp group. So this is what we can take for now. So when we meet, I've sent the timetable in the group. So when we meet again, we'll go to more complex stuff. So this was just an intro. This is just a crash course. So this was just an intro. So make sure that you practice, master it. Remember, maths, if you don't know the basics, forget about the complex one, forget about the advanced one. Maths is like a foundation. The basics are foundation. You cannot build a house without a foundation. Where you gonna lay the bricks without a foundation? So these are just basics. What I want you to do, I'm gonna give you tons of work. I want you to go through the work. Don't say it's easy, because once you say it's easy, you will not understand the complex stuff. So just do it. Someone is asking, how do you identify a geometric sequence? Okay, so remember we have two sequences. Two types. We have arithmetic and geometric sequence. So the geometric, okay, I think it's explained. So if you say T2 divided by T1 and T3 divided by T2 and T4 divided by T3, it should give you the same answer. That will be a geometric. So if it's giving you a different answer, so you should consider that as an arithmetic. So arithmetic, instead of say divide, you say minus. See? Yeah, so you are answered well there. All right, I hope you are following. Okay, perfect, cool. All right, thank you so much for watching. Remember, you can invite your friends to participate. So we are getting there. So next time we're meeting, we're gonna do more complex stuff, talk about sigma notation. Yes, those wonderful stuff. So those ones are easy if you understand the basics, because you just use a formula, you just substitute, then you get the right answer. Thank you so much for watching. So remember to share our Facebook page with your colleagues, with your classmates, with your friends, and also hit the like button on our YouTube channel and subscribe, so that you can get updates every time we post our content on YouTube. So we're dealing with from grade 8 up to tertiary level. We're doing maths for up to tertiary level as well. Thank you so much for watching. All right, good night and bye bye. See you next time. Remember to check out our timetable. We send our timetable on the group, on the WhatsApp group. Thank you so much. So I'm gonna send you a homework in 30 minutes time. So it's a lot of homework. Please do it. It's a lot, a lot, a lot, a lot, a lot, a lot. Just take your time and do it. And you need to submit it at least by tomorrow. So you have tonight. Maybe you can do 2 or 3 tonight, so that you can make sure your brain is working. You can do maybe 2 or 3, so that when you sleep you don't forget what you've learned. Remember, you can always go through to our Facebook page or to our YouTube to watch the lesson again and again and again until you understand. But if there's any challenge, you can also reach to us. Thank you so much.